A plane left half an hour later than the scheduled time, and in order to reach its destination 1500 kilometers away in time, it had to increase its speed by 33.33% over its usual speed. Find its increased speed is the question. So basically a plane left half an hour later, right? It left half an hour later than the scheduled time. And in order to reach its destination, which is 1500 kilometers away in time, it had to increase its speed by 33.33% over the usual speed. Find the increased speed is the question. Find the increased speed is the question. So if you see, the distance to be covered is 1500 kilometers. The distance to be covered is 1500 kilometers. Let us assume the usual speed is s and the usual time taken is t. What is the new speed? The new speed is s plus 33.33% of s. Increased speed, right? It had to increase its speed by 33.33% over its usual speed. Why did it do that? Because it started half an hour later. And even though it started half an hour later, it wanted to reach the destination in time. So if earlier the plane had taken t hours, now the plane will take only t minus half hour. T minus half hours. Yes or no? If earlier the plane had taken t hours, now it has got only t minus half an hour, t minus 30 minutes. Why? It started half an hour later, but still it reached in time, right? It wanted to reach in time, so it will have half an hour less. So that's the case basically, right? Two different cases. In the first case, the usual speed is s, the time taken is t to cover 1500 kilometers of distance. In the second case, to cover the same distance of 1500 kilometers, the speed was s plus 33.33% of s, which is basically, 33.33% is s by 3. S plus s by 3 is 4s by 3. That's the new speed, and the new time, as we know, is t minus half. So new speed, new time, original speed, original time, and distance in both the cases is 1500 kilometers. We have to find its increased speed. Increased speed is 4s by 3. Let's say this is like s dash and t dash. So increased speed s dash has to be calculated. Now how do you do it? I mean, one simple point to be noticed: in both the cases the distance is same. The distance traveled is same. What is distance speed into time, right? Distance traveled in case 1, if you say the distance here is d dash is also 1500 kilometers, right? So d is equal to d dash. What is distance speed into time? So s into t is equal to s dash into t dash. Try to solve this. S into t as it is. S dash will be 4s by 3 into t dash is t minus half. So s gets cancelled. You will be able to find out t from this. How much will t be? We have t equals to 4t by 3 minus 4 by 3 into 1 by 2. So that's like 2 by 3. Simplify this, what happens? 4t by 3 minus t equals to t by 3. T by 3 equals to 2 by 3. So t is equal to 2 hours. So basically the original time is 2 hours. Now what do you do? Once you have got one of the variables, you can find out the other variable very easily. Right? If t is equals to 2 hours, what is t dash? T dash will be equals to 1.5 hours. Because t dash is t minus half, right? T dash is t minus half. So 2 minus half is 2 minus 0.5, 1.5 hours. T dash is 1.5 hours. Now substitute this t dash in the same equation. See, we know that it's like this. We know that d dash is equals to s dash into t dash, which means 1500 is equals to s dash into t dash is how much? 1.5. So what is s dash from this? 1500 by 1.5, 1000. So we can say the speed is 1000 kilometers per hour. S dash. See, what is he asking us to find out? Find the increased speed. Increased speed is nothing but s dash. S dash is equal to what? So that is the reason we have used this equation. Second equation, s dash into t dash. Or maybe you find the original speed. Even that will help us. Original time is 2 hours, right? To cover 1500 kilometers, if we take 2 hours, what will be the speed? 1500 by 2. 1500 by 2 is 750. The original speed is 750. What's the increased speed? 750 plus 33.33% of 750. That way also we will get same 1000 kilometers per hour. So basically this is what has to be done to get the answer. But then cut down all the unnecessary steps. I mean, the solution is not as lengthy as you see it here, right? I mean, you don't have to write d 1500, d dash 1500, s t, s dash t dash, s plus 33.33% of s, t minus half, 4s by 3, t minus half. All this is waste of time. D equals to d dash, s into t equals to s dash into t dash. No. You should start from this step onwards. S into t equals to 4s by 3 into t minus half. From that calculate t. And once you get t, I think after that it's mental calculation, right? If t equals to 2 hours, you know that S will be 750. The new speed will be 750 plus 750 by 3. 750 by 3 is 250. So 750 plus 250, 1000 will be your answer. You don't even have to do this. You can even cut this step down. So if you see, there's not much to be written on paper, right? Very easily you can simplify this and get the answer. Answer would be 1000 kilometers per hour, right? 1000 kilometers per hour. But then let me show you another method of solving this question, right? Let's do it in another way, right? Here we are going to use this concept of percentages, which will make the solution even simpler. Now I want you to go back and refer to this model 6 or model 5. I don't know which model of percentage exactly, but where we have talked about effective percentage. You remember the concept of effective percentage, right? The concept of effective percentage. So we will use that now, right? Using effective percentage, how do we solve this question? Let me show that to you. Effective percentage. Now, if you understand, we know that distance is equal to speed into time. Distance is equal to speed into time. If you observe in the two cases that we have discussed here, in original case, there is some, usual speed, usual time taken. In the new case, there is new speed, and because of which there is a new time. But then the distance is same. See, you know that if speed increases by A% or speed changes by A% and the time changes by B%, if speed changes by A%, time changes by B%, then overall the distance will change by what percent? A plus B plus AB by 100%. Because if you go back to that video of effective percentage, the video where we have discussed the effective percentage concept, I told you, whenever we have anything in this format, where one variable is equal to the product of the other two variables, then effective percentage concept can be applied. Like for example, area of a rectangle. Remember, area of a rectangle. What is area of a rectangle? Length into breadth. So I told you, if length increases by A%, breadth increases by B%, then area will change by A plus B plus AB by 100%. Or similarly, we discussed about let's say total revenue. What is revenue? Revenue is equals to price into quantity. So if price changes by A%, quantity changes by B%, what will be the change in revenue? A plus B plus AB by 100%. Or total sales. Total sales is also price into quantity, revenue or sales, right? Or I think we have discussed examples on expenditure. Expenditure of a person. Expenditure of a person is also what? Price into quantity. The price that he pays per kg into the number of kgs that he buys. So in case of expenditure also, if the price changes by X%, quantity changes by Y%, what will be the change in expenditure? X plus Y plus XY by 100%. So same happens in distance also. Distance, since distance is equal to speed into time, if the speed changes by, let's say, A%, time changes by B%, we can always calculate distance, the change in distance as A plus B plus AB by 100%. Now, in this particular case, if you observe, the distance is same in both the cases. The distance covered was not changed, right? D equals to D dash. Look at this part. That's what we did, right? D equals to D dash. Originally, the plane has to cover 1500 kilometers. After starting half an hour late also, with increased speed, it has to cover the same distance, 1500 kilometers. So basically, we are saying that A plus B plus AB by 100% is equal to 0. This is equal to 0. There is no change in the distance. Is there any change in the distance? No, there is no change in the distance. We have discussed such cases in expenditure also. By how much should a family reduce its consumption so that the expenditure remains constant? The price of rice increased by X percentage. The price of rice increased by 25%. The price of rice, let's say, increased by 33.33%. So by what percentage should a family reduce its consumption of rice or sugar or whatever the item is so that the expenditure remains constant? Something like that is happening here. Are you able to follow? The distance is constant, but the speed has increased by 33.33%. The speed has increased by 33.33%. Now, if you are good in playing with these values, you will be able to solve the question very easily. I know that if the speed has, so basically if the speed has increased by some percentage, the time has to decrease. Only then the distance can remain constant. That's what has happened here, right? Why did the speed increase by 33.33%? Because the time decreased by half an hour. The time was, half an hour less. The time given was half an hour less. So when the speed has increased by some percentage, time should reduce by some percentage, some other percentage. Here we know that the speed has increased by how much percentage? 33.33%. Speed increased by 33.33%. Remember, if speed increases by 33.33%, the time will reduce by 25%. time will reduce by 25%. If speed has increased by 33.33%, then time will reduce by 25%. Now this percentage calculation also has been discussed in the topic of percentages. See, basically what is it? 33.33% like 1 by 3. 33.33% is equal to 1 by 3. We want to reduce. I explained this concept of fractions, right? 1 by 3 should be reduced. How will you reduce the fraction? By increasing the denominator. By how much will you increase the denominator? Increase the denominator by 1. Why are we increasing the denominator by 1? Because the numerator is equal to 1. So 1 by 3 will become 1 by 3 plus 1, 1 by 4. So that's the point. If the speed increases by 1 by 3, time reduces by 1 by 4. 1 by 4 is 25%. And this, a smart person would remember. You are expected to remember certain values, right? So if the speed goes up by 33.33%, time will come down by 1/4, which is 25%. I'll tell you a better way of remembering it. We'll look at that a few seconds later. But the point is, if the speed has increased by 33.33%, time should reduce by 25%. In the given question, I know that the time is reduced by half an hour. In the given question, we very well know that time is reduced by half an hour. So can I say 25% of the time is equal to half an hour? Yes. If 25% of the time is half an hour, the total time 100% will be equal to 2 hours. If 25% is half, 30 minutes, 100% will be 30 minutes into 4, 120 minutes. 120 minutes is 2 hours, which means originally you took 2 hours to cover 1500 kilometers, which means your original speed was 1500 by 2, 750. We are arriving at the same thing. Instead of using the equations and all that, I am saying just go by this concept of percentages. 25% is equal to half an hour. I'll clear this up, right? I mean, this we have already discussed. One method we have already discussed. Let me just explain what are we doing with this percentages, right? Let me just explain that. So basically, we have realized that the time has to reduce by half an hour. Here, speed has increased by 33.33%, which is like 1 by 3. Implies the time has to reduce by 25%. Which is equal to 1 by 4. I am writing this 1 by 3 and 1 by 4 in the bracket so that you can understand what is that calculation behind 33.33 versus 25, right? I have explained you this fractions concept in the video, percentages video. Now, I know that the time reduced by half an hour. So, can I say 25% of the time is equal to half an hour? Yes. Which implies the total time t is equals to 2 hours? Yes. That's it. So, I can say that the original speed s is equal to distance by time, which is equal to 1500 by 2. You don't have to write these steps. I am writing it so that I can explain it to you. You don't have to write this in the exam. 1500 by 2. 1500 by 2 is 750. 750 kilometers per hour. I can say that the original speed is 750. That's it. Once you get the original speed, find the... I mean, question can be anything. Here he's asked us to find out the increased speed. Maybe he'll ask you to find out the original speed. Original speed 750. Increased speed. How much is the increased speed? S dash. Increased speed is original speed plus 1/3 of original speed. 33.33%, right? 750. Which comes out to be 1000. While I have written so many steps on paper, believe me, if you solve using this concept of percentages, you will get the answer without putting pen on paper. All these steps can be avoided. I'll just look at the values and get the answer as 1000 kilometers per hour without putting pen on paper. Without putting pen on paper. Because all the calculations are easy. 25% is half an hour, which means total time is 2 hours. If total time is 2 hours, original speed will be 1500 by 2, 750. If original speed is 750, new speed will be 750 plus 1/3 of 750, which is 250. 750 plus 250 is 1000. What is complex about it? Okay, maybe the only complexity here, could be this part, 33.33% and 25%. So let me make this also very simple for you. How do you do this? Very easy to remember. Certain values are very, very easy to remember. I'll tell you how to get that value without even doing that fraction based calculation. See, one thing is you use these fractions. 1 by 3 will become 1 by 4. 1 by 4 will become 1 by 5. 1 by 5 will become 1 by 6. I mean, that's the whole concept, right? But instead of that, there is an easier way to remember. See, already in the percentages video, I have told you, I have already told you that you have to remember certain fractions, like 100% is equal to 1, right? 50% is equal to 1 by 2. 33.33% is equal to 1 by 3, 25% is equal to 1 by 4, 20% is equals to 1 by 5, then 16.66% is equal to 1 by 6, then 14.2857% is equals to 1 by 7, and so on. 12.5 percentage is equals to 1 by 8 and so on. Now very simple. If the speed has increased by 33.33 percentage, time will be reduced by 25 percentage. As simple as that. Immediately next value will be the reduction. Whether it is speed, time, length, breadth, price, quantity, anything. When you are looking at like S into T type of equation, if one increases by any of these values, the other would decrease by the immediately next value. Like for example, if the question says speed increased by 16.66 percentage, you can come to a conclusion that the time will reduce by 14.287 percentage. Suppose the question says speed increased by 25 percentage, time will reduce by 20 percentage. If the question says speed increased by 100 percentage, time will reduce by 50 percentage. If the speed increased by 50 percentage, time will reduce by 33.33 percentage. If the speed increased by 33.33 percentage, time will reduce by 25 percentage. If the speed has increased by 20 percentage, time will reduce by 16.66 percentage. If the area increased by 50%, if the length increased by 50 percentage, breadth will decrease by 33.33 percentage. If the length increased by 25 percentage, the breadth will decrease by 20 percentage. You getting it? If the price has increased by 25 percentage, the quantity will reduce by 20 percentage. If the price has increased by 16.66 percentage, the quantity will reduce by 14.28 percentage. So basically the whole concept is effective percentage. And if you kind of recall, when we were discussing about effective percentage in the video, I must have told you that this is one of the most important techniques that you must learn and use effectively. And in the introduction video of percentages, I also told you that percentage is a concept in general which is important not only for solving questions of percentages, but also from profit and loss, simple and compound interest, time and work, and time and distance. And here is an application in time and distance. Are you able to follow? So I know that speed increased by 33.33% in the question, which means time reduced by 25%. But time actually reduced by half an hour, so I can say 25% equal to half an hour, which means total time is 2 hours. If the total time is 2 hours, the original speed will be 1500 by 2, which is 750 kilometers per hour. If the original speed is 750 kilometers per hour, the new speed will be 750 kilometers per hour plus 33.33% of 750, which comes out to be 1000. So my answer is 1000. How much time? Less than 15 seconds. Less than 15 seconds. As simple as that. So without putting pen on paper, you will be able to solve this question, provided you know the concept of effective percentage very well and you have practiced on your calculations. Because without being able to do calculations, you will not be able to solve these questions easily.